Hi students, this is Mukesh here. So here we start with differentiation. This is the first lecture of differentiation, a very important topic of calculus. It has a lot of applications in physics, in many chapters of maths, even in economics also. So we define what is differentiation or how to find the derivative. Okay. So if y is a function of x, now y is a function of x means y depends on x. You've studied that in function. So if I make a small change in the value of x, there is a change in the value of y also. Okay. So the rate of change of y with respect to x, the rate of change of y with respect to x is called the derivative of y with respect to x. Okay. So I repeat again, if y is a function of x, then the rate of change of y, that rate of change word is very important. It's very important for the other topics also. So rate of change of y with respect to x is called the derivative of y. It's called the derivative, or it's also called as differential coefficient. It's called derivative or differential coefficient of y with respect to x, and is denoted as dy by dx. This is denoted as dy by dx, or it's f dash x. F of x ka derivative is f dash x, or in some books written as y1 also. It's y1. Derivative of y is y1. Okay. So it's dy by dx or f dash x or y1. So if you make a small change in the value of x, then the change in y, or you say the rate of change of y with respect to x is called the derivative of y with respect to x, and that's denoted as dy by dx or f dash x. Okay. Now here remember that d by dx is the derivative operator. Okay. So I made you write note there. The symbol d by dx is called the derivative operator. Operator means जब वो आएगा तो you have to operate derivative. I'll tell you what it is. Derivative operator with respect to x. So when you have x here, if you have d by dx, then it's the derivative with respect to x. If you have d by dt, it's going to be derivative with respect to t. So if you write here derivative of d by dx of, suppose I write y, then it becomes derivative of y with respect to x. Okay. If I write derivative of u, then this becomes du by dx. So derivative of, you pronounce that as derivative of u with respect to x. Clear? If I write derivative of tan x, then you pronounce this as derivative of tan x with respect to x. Clear? So see that the symbols are clear to you. If you have derivative of, suppose say x with respect, this dx by dt. So dx by dt is called derivative of x with respect to t. Clear? So it's derivative of x with respect to t. In physics, dx by dt means velocity, where s is the displacement. So basically velocity is called the rate of change of displacement. Fine. So ds by dt means the rate of change of displacement with respect to time is called as velocity. dv by dt is the rate of change of velocity with respect to time. That is called as acceleration. So here v stands for velocity. In economics, derivative of demand with respect to supply is denoted as derivative of capital D, where capital D denotes the demand, with respect to x, S, that's supply. So derivative of demand with respect to supply is denoted as derivative of D, capital D, with respect to S, or it's also called as marginal demand. So wherever you find the word marginal means you have to take the derivative. Okay, so it's called marginal demand. So these are the applications. Now we go to the standard formulas of derivatives. Okay, so here we start with standard derivative formulae. See that you learn the formulas. You should be very thorough with the formulas, and then you apply the formulas in the sums, and that's how you operate derivatives then. So the first formula is derivative of algebraic function x raised to n. You have x raised to some number. Okay, so the first formula is derivative of x raised to n. Derivative of x raised to n. Now x raised to n, the derivative is n into x raised to n minus 1. Please understand this. It's going to be n into x raised to n minus 1. N into x raised to n minus 1. For example, if you have derivative of x raised to 7, then you have to bring the 7 to the base and reduce the power by 1. So it becomes 7 into x raised to 7 minus 1 becomes 6. Clear? If you have x raised to 10 here, if you have x raised to 10, then the formula becomes 10 into x raised to 10 minus 1. So 10 into x raised to 10 minus 1 will become 10 into x raised to 9. Clear? So now come on, you answer me. What is the derivative of x square? So derivative of x square will be what? So x square में 2 नीचे आएगा. It's going to be 2x raised to 1. That's 2x. What's the derivative of x raised to 4? So it's going to be 4 into x raised to 3. Clear? Derivative of x raised to 20. If you get x raised to 20, the answer will be 20 into x raised to 19. Is that clear? X raised to 100. Tell me orally, x raised to 100. It's going to be 100 into x raised to 99. Let's take a fraction. Derivative of x raised to 3. What's the derivative of x raised to 3 by 2 now? 3 by 2. So here the answer will be 3 by 2 into x raised to 3 by 2 minus 1. 3 by 2 minus 1 is 1 by 2. 3 by 2 x raised to 1 by 2. Take one negative number. What's the derivative of x raised to minus 2? Now x raised to minus 2, that will be minus 2 into x raised to minus 2 minus 1. So that will become minus 3. Clear? You have this formula later also. So the first formula is x raised to n. X raised to n, the derivative is n into x raised to n minus 1. The formula is n into x raised to n minus 1. Clear? It's n into x raised to n minus 1. ये formula तब use करना है when you have x as the base, the variable is the base, okay, and the power is a number. Power is a number. The second formula is derivative of a raised to x. The second formula is derivative of a raised to x. Here a is a number and the power is a variable here. So this is called as exponential function. So a raised to x, the derivative is a raised to x into log of a. A raised to x into log of a. A raised to x into log of a. If it is e raised to, and here the base of log is e, okay? So remember the base is always e. If you have e raised to x, the next formula is e raised to x. E raised to x, the derivative is e raised to x into log of e to the base e आएगा, right? Same formula से. So log of e to the base e becomes 1. So this value becomes 1, so it will become e raised to x. Clear? So a raised to x का derivative is a raised to x into log a, and e raised to x का derivative is e raised to x. Now the difference between the first formula and the second formula is, in the first formula, the base is a variable and power is a number. Here, the base is a number and power is a variable. So don't get confused while applying the formula. For example, if I ask you, what is the derivative of 5 raised to x? So you apply the first formula or second formula? Yes, we apply the second formula because the base is a number. So here the answer will be 5 raised to x into log 5. 7 raised to x, it's 7 raised to x into log 7. 10 raised to x, it's 10 raised to x into log 10. Clear? But if you have derivative of x raised to 5, x raised to 5, then here we use the first formula. The first formula is 5 into x raised to 5 minus 1, that's 4. Clear? So the first formula is x raised to n, it's n into x raised to n minus 1. Second formula is a raised to x. A raised to x, the derivative is a raised to x into log a. E raised to x, the derivative is e raised to x. The fourth formula is derivative of trigonometric functions now. So you have sine, cos, tan, cot, sec and cosec. Okay. So derivative of sine x. Sine x ka derivative is cos x. Sine x the derivative is cos x. Derivative of cos x is equal to minus sine x. I repeat again. Sine x derivative is cos x and cos x ka derivative is minus sine x. Then you have tan x. Tan x ka derivative is x square x. Sec square x. Okay, and cot x का derivative is minus cosec square x, minus cosec square x. See that again, sin x, the derivative of sin x का derivative is cos x का derivative is minus sin x. Then tan x derivative is x square x, and cot x का derivative is minus cosec square x. Clear? The next formula is derivative of sec x. Now sec x का derivative is sec x into tan x, sec x into tan x, sec x into tan x. Cosec x का derivative is minus cosec x into cot x, minus cosec x into cot x. It's minus cosec x into cot x. So see that again, the derivative of sin x is equal to cos x, and cos x का derivative is minus sin x. Tan x का derivative is x square x है, tan x का derivative is sec square x, and cot x का derivative is minus cosec square x. Then derivative of sec x is equals to sec x into tan x, and derivative of cosec x is equal to minus cosec x into cot x, minus cosec x into cot x. The next is derivative of log x. The log का base should be e. Okay, अगर कुछ भी नहीं दिया तो उसका base e है, या फिर यहाँ पे e दिया होगा. Is that clear? So the base of log is always e. So the derivative of log x का derivative is 1 upon x. Log x का derivative is 1 upon x, 1 upon x. But if the base is not a, e, suppose some other number is given, or base में suppose they give you a or 10, then you write the formula as 1 upon x log a. 1 upon x log a. Okay, so log x का derivative is 1 by x. Log x का derivative is 1 by x, and if you have some other base, then it's going to be 1 upon x log a if the base is a. The next formula is 1 by x. Now 1 by x comes from the first formula. 1 by x is actually what? X raised to minus 1. So you can use the first formula, minus 1 into x raised to minus 1 becomes minus 2, and when you solve that you get answer then, right? So we have a formula for this. 1 by x ka derivative is minus 1 by x square. The formula is minus 1 upon x square, minus 1 upon x square. If you have 1 upon x square, then the derivative is minus 2 upon x cube, minus 2 upon x cube. I repeat again, the derivative of 1 by x ka derivative is minus 1 by x square. If you have x raised to 1, the formula becomes minus 1 upon x raised to 2. If you have x raised to 2, then this becomes minus 2 into x raised to 3. Minus 2 into x raised to 3. Similarly, you tell me, what is the derivative of 1 upon x cube then? If you have derivative of 1 upon x cube, that will become minus 3 upon x raised to 4. Derivative of 1 upon x raised to 4, then you can call that as minus 4 upon x raised to 5 and so on. Okay, so derivative of 1 by x ka derivative, 1 by x ka derivative is minus 1 by x square, and 1 by x square is minus 2 upon x cube. The next formula is derivative of root x. This is very important, derivative of root x. This also comes by the first formula. Root x is actually x raised to half, right? So when you use the first formula, this becomes half into x raised to half minus 1. And when you simplify that, your answer will be 1 upon 2 root x. 1 upon 2 root x. So by head this also, root x ka derivative is 1 upon 2 root x. 1 upon 2 root x. The next formula is derivative of x. Now derivative of any function with respect to the same function. Derivative of x with respect to x. Here you have derivative of x with respect to x. So x ka derivative is equal to 1. Clear? So derivative of x with respect to x is 1. If you have a constant kx, then it's going to be k. Derivative of 2x आया तो लिखने का 2. Derivative of 3x आएगा, the answer is 3. Derivative of 4x आया, the answer is 4. Derivative of 5x, the answer is 5. Derivative of kx is equals to k. Clear? So x का derivative is 1 and kx का derivative is k. And if you have derivative of any constant, मतलब उसमें x नहीं है, then the constant का derivative is always 0. There is no x here, so there is no change also. No change means value is 0. So derivative of any constant is equal to 0. For example, you have derivative of phi. So phi is a constant, there is no x term here, the derivative is equal to 0. Clear? The next is inverse trigonometric functions. Now derivative of sine inverse x. Sine inverse x, the derivative is 1 upon root of 1 minus x square. The formula is 1 upon root of 1 minus x square. Sine inverse x, the derivative is 1 upon root of 1 minus x square. When you have cos inverse x, then the formula is negative, minus 1 upon root of 1 minus x square. Okay, sin inverse x का derivative is 1 upon root of 1 minus x square. Cos inverse x, the derivative is minus 1 upon root of 1 minus x square. Then you have tan inverse and cot inverse x. So remember, sin inverse x, cos inverse x, the formulas are same. You have a minus sign in cos. Here it's 1 upon root of 1 minus x square. Here it's minus 1 upon root of 1 minus x square. Clear? Then you have tan inverse x. Tan inverse x ka derivative is 1 upon 1 plus x square. 1 upon 1 plus x square. And cot inverse x, the derivative is minus 1 upon 1 plus x square. There is no root here now. So check again. Sin inverse x, the derivative is 1 upon root of 1 minus x square. Cos inverse x, the derivative is minus 1 upon root of 1 minus x square. Tan inverse x, the derivative is 1 upon 1 plus x square. And cot inverse x, the derivative is minus 1 upon 1 plus x square. The last formula, derivative of sec inverse x. Now sec inverse x, the derivative is 1 upon x into root of x square minus 1. It's 1 upon x into root of x square minus 1. 1 upon x into root of x square minus 1. Cosec inverse उसका negative है, तो it becomes minus 1 upon x into root of x square minus 1. So please learn all the formulas thoroughly. Then you can learn the rules and start the sums there. Okay. So just go through that. The first formula was x raised to n. The derivative of x raised to n was n into x raised to n minus 1. Here you apply the formula when you have x raised to number, x raised to number. The second formula is number raised to x. So derivative of a raised to x is equal to a raised to x into log a. Derivative of e raised to x is going to be e raised to x into log e is 1. So it's basically e raised to x. Derivative of sin x is equals to cos x. Derivative of cos x is equal to minus sin x. Derivative of tan x is equal to sec square x. Derivative of cot x is equals to minus cosec square x. Derivative of sec x is equals to sec x into tan x. Cosec x का derivative is minus cosec x into cot x. Minus cosec x into cot x. Log x का derivative is 1 by x. Log x का derivative is 1 by x. That's very important. But the base of log should be e. Nothing is given that its base is e. अगर कुछ और base a आया तो formula will become 1 upon x log a. 10 आया यहाँ पे तो 1 upon x log 10 आएगा फिर. Okay. Then the derivative of 1 by x. 1 by x का derivative is minus 1 upon x square. 1 by x square आया, it's going to be minus 2 upon x cube. 1 upon x cube, it's going to be minus 3 upon x raised to 4. 1 upon x raised to 4 will be minus 4 upon x raised to 5 and so on. Then root x, derivative of root x is equals to 1 upon 2 root x. It's 1 upon 2 root x. 1 upon 2 root x. Root x ka derivative is 1 upon 2 root x. That's very important. X ka derivative with respect to x is equal to 1. Derivative of any variable with respect to the same variable is always equal to 1. Okay. If you have derivative of x, it's going to be 1. 2x आया तो 2, 3x आया तो 3, 4x आया तो 4. So kx का derivative आया तो it's going to be k. And if you have only constant, no x term, then the derivative is equal to 0. For example, phi ka derivative is 0. Clear? Then you had inverse functions. Derivative of sin inverse x is equals to 1 upon root of 1 minus x square. And cos inverse x is equal to minus 1 upon root of 1 minus x square. Both the formulas are same. There's a difference of sign here, positive and negative. Similarly, tan inverse, cot inverse. Tan inverse x ka derivative is 1 upon 1 plus x square. 1 upon 1 plus x square. And cot inverse x is minus 1 upon 1 plus x square. Finally, sec inverse x, the derivative is 1 upon x into root of x square minus 1. And cosec inverse at same formula minus sign. It's minus 1 upon x into root of x square minus 1. Clear? So these were the formulas. Learn the formulas thoroughly. Then you have rules of differentiation. Now if you have sums, then how to differentiate when there's 2 function, 3 function, 4 functions having plus sign, minus sign, multiplication, division. So for that you have to study the rules here. So the first rule. Now generally if u and v are differentiable functions of x. So you have studied so many functions ka formula. Suppose u is sin x, v is log x. So u is any function of x, v is any function of x. So if u and v are differentiable functions of x, okay, then what's the derivative of k into u? K is a constant, k into u. So what do you do here? You have to keep the constant out, and take the derivative of u. Take the derivative of u. Okay. For example, if I ask you, what is the derivative of 4 tan x. So here tan x is the function, 4 is a constant. To keep that 4 out, it's going to be derivative of tan x, right? But we can write directly the answer as 4 into derivative of tan x. Derivative of tan x is sec square x. The answer is 4 sec square x. So in sums, you can directly write this. Derivative of 4 tan x is equal to 4 sec square x. Clear? The next formula is the derivative of sum of two functions. We have one function u, another function v, and there's a plus sign between them. Then you can take the derivative inside, and this becomes derivative of u. It's going to be derivative of u plus derivative of v. So derivative of u plus v as is going to be first derivative plus second ka derivative. If you have a minus sign between them, so use the same formula, there will be a minus sign here. So let's take an example. Suppose I ask you what's the derivative of log x plus root x. So you can take the derivative inside. This becomes derivative of log x plus derivative of root x. And you can write the answers. Log x ka derivative is 1 by x and root x ka answer is 1 by 2 root x. Clear? So you can write the answer directly. Again I am saying log x ka derivative is 1 by x and root x ka 1 by 2 root x. They have a plus sign between them. So the answer will have plus sign between them. Clear? If you have minus sign, then it's going to be the same rule. Now if I merge the first and second rule, listen here everyone. What about the derivative of a constant into a function u plus or minus a constant, other constant to that of v into v? So you have to keep the constant out, k1 into that of first function plus or minus whatever you have, k2 into derivative of second function. Clear? So it's going to be derivative of first function plus derivative of second function. If you have constants, then keep the constants out. Okay. So if you have constants here, then this becomes derivative k1 into that of u plus k2 into derivative of v. Fine. The third formula is product rule. Now these two are very important. If you have two functions ka multiplication, so that is called as product rule. So what's the derivative of u into v now? So u into v means the formula is u into derivative of v plus v into derivative of u. It's first into derivative of second plus second into derivative of first. Keep the first term as it is into take the derivative of second plus second term as it is into derivative of first. So let's take one example here. What's the derivative of root x into tan x? So you can imagine the first function as u and this function as v. Now apply the formula. So the answer will be root x into derivative of tan x. Root x into derivative of tan x is sec square x plus tan x, second term वैसे लिखना है, into root x का derivative. Root x का derivative is 1 upon 2 root x. Clear? Let's take one more example. Tell me, you all tell me what's the derivative of x raised to 7 into log x. So you can imagine the first term as u and second term as v. When you use the formula, the answer becomes x raised to 7 into derivative of log x is 1 by x, right? Plus log x into derivative of x raised to 7 is 7 into x raised to 6. So here you can cancel one x and the answer comes out to x raised to 6 plus 7x raised to 6 into log x. Clear? So this is very important. The formula for the multiplication of two terms, it's called product rule. It's going to be first into derivative of second plus second into derivative of first, or you can say it's u into derivative of v plus v into derivative of u. And the last rule, it's called the quotient rule. This is for division. That's called as quotient rule. Derivative of u upon v, u upon v. Here we start with the denominator. Okay, it's v denominator into derivative of numerator minus numerator, it's minus, minus numerator into derivative of denominator, the whole upon denominator square. The formula is v into derivative of u minus u into derivative of v the whole upon denominator square. It's v square. Clear? Right? Take one example here. Tell me what's the derivative of log x upon x square. So how do you solve this? So you start with the denominator. What is the denominator? X square into derivative of log x. X square into derivative of log x. What's the derivative of log x? 1 by x, right? Minus log x, second term, into derivative of, the denominator into that of numerator. I start with the denominator first. So it's denominator into that of numerator minus numerator into derivative of denominator. What's the derivative of denominator is 2x. The whole upon denominator ka square. Clear? So when you cancel, this becomes x minus 2x log x upon x raised to 4. Or you can take x common and cancel. You can take x common from the numerator and cancel. The answer becomes 1 minus 2 log x upon x cube. So the formula is denominator. Start with denominator, okay? So the formula is denominator into derivative of numerator minus numerator into derivative of denominator upon denominator square. It's v into derivative of u minus u into derivative of v the whole upon v square. Whole upon v square. Is that clear to all? So see that you learn the formulas and rules thoroughly, and we can solve sums based on these formulas and sums in the next class. Okay.